Let's go. Hello, everyone. So welcome to this talk on how you can be super productive with Spring Boot. My name is Stéphane Nicoll. I'm working on the Spring Boot team and the Spring Framework team.
My name is Brian. I'm working on Spring Framework, and I'm also working on the new reactive efforts for Spring.
So before you wonder, everything we're going to show you today will be pushed on this GitHub repository. So if you want to take a picture, now is the time.
Meanwhile, we can ask a few questions to the audience, because we always like to know what you guys are doing. So in case you're, do you know, who knows Boot? Okay, obviously, you've been there this morning. Who's using Boot?
In the back. I can't see in the end. Okay.
Good. Now the version, maybe?
Yeah, the version 1.2. No, 1. 1.3.
Okay.
1.4 milestones. Okay, a few
Thanks.
brave. That's good. Okay, so after the talk, if you want to discuss, obviously you can come to us. If you want to complain even more, you can use those Twitter accounts. And that will be it for the slides, so no slides today. What we want to do is, we do that quite often actually, is to start with a simple app, just show you what it does, and improve a few features with live coding and explaining how the feature is working in Spring Boot. So we've chosen for that, application failed to start. Okay, that was unexpected. That's not part of the demo.
You've got something running?
I got something running somewhere. Do I? Okay. Still the old app or what?
You've got the Keynote application running somewhere.
Why? Why? Okay, you need to dance now while I'm fixing this.
Okay. So what we wanted is, with that application, the base of that application is a call for paper application. With that application, you can submit submissions for a conference. We'll see how it goes. And it's a basic Spring Boot application using Spring Boot 1.4 milestone. And with all this, we will show a few tricks on how you can be more productive and how you can achieve some things that were harder to do previously, and now you'll see how you can do those with the latest version of Boot. So it's working. Yeah, it's working now.
Okay, great.
So that application looks like this. We've got a home page. We've got a few things. We're getting some information out of GitHub. We're fetching, using the GitHub API, we're fetching the latest commits of the Spring Boot and Spring Framework projects. We're doing the same thing on our news page. We're getting a few commits, and we even have a pretty sign saying 2 days since the last Polish commit, since it tends to happen a lot on our repositories.
And some kind of conference hassle, because yesterday we realized that something was broken and we had to revert to the snapshot. So that's why you have this wonderful revert commit here.
Living on the edge.
Yeah, definitely. And only 2 days since last Polish. Okay, so if you want to submit something to this conference, you go here, you fill in your data. So let me do that quickly.
Simple form with email, name, title, summary, and you can choose what track you want to submit your talk to.
Okay, and if I do that, I have a talk which is submitted,
which
creates something in the data store. And there is also this login button, which redirects me to this page. So it's admin123. We'll explain that in a minute, if I can type.
So right now, it's a simple Spring Security configuration, and we'll show you that configuration. And within the admin dashboard, you only see a list of all these submitted talks.
Okay, so let's see quickly the code now. We have a security config, which we'll need to improve, because basically anyone can submit anything. You don't have to log into this application to submit a talk, which is something that we would like to improve. So you have permit all here on submit, which is probably something that we don't want to do. We call GitHub, and GitHub actually has a rate limit of 60 calls per hour if you're not authenticated, so as a public user. which will probably be an issue for this presentation. So
Yeah.
what we've done is we've created an access token, an application access token, that we inject in this property here. This will be probably the first, and I hope last time you see a presentation of ours using add value, because there is way better option in Spring Boot these days. But anyway, I'm injecting this environment properties that I've set locally, and I'm using it to construct a REST template, so which will send the header every time to avoid going on the rate limit. So if we go here, I have this script prepared for you, where I can see that the amount of call I can do for the remaining hour is almost 5,000. So if you are authenticated, it's 5,000. If you're not, it's 60.
Okay.
Right. So you've seen that thing during the keynote. We want to do it again because we are going to show you more things that what was shown during the keynote and more explanation because we have more time. So I'm going to create a template this time. During the keynote, it was a static asset, but here I'm going to create a template.
Yeah. So this time it will be processed by the engine, by the real template engine.
If I do that, I have my error page showing up. We will improve it shortly. So DevTools, how does it work while I'm fixing stuff?
How does it work? So so when you are starting your application with DevTools, part of your application, all the libraries your application is using are stored. I mean, you're using a separate class loader for this, or your custom code is living in a separate class loader. And whenever there's an event going on in your application, so you're changing something in your application in a static file, in a class file, then DevTools pick those events and is doing the right thing. So just signaling your browser through live reload that something changed, or restarting the context, the Spring context, to pick those changes because you just did something. But because because of those separated class loaders, it's really starting really fast.
So so DevTools is really smart about whether it's resources, you can just refresh the browser and it will work, or if it really needs to restart the application. In this case, I'm going to change a template. So there is some text here. Let's put something like, I don't know, share your patient or whatever. And if I rebuild, then DevTools will know about it, and it will instruct the browser to reload. So that's this live reload extension. It's a free plugin you can install. And when you use that plugin, basically your application connects to the browser and can send instructions to it.
In that case, we only change a static asset, so we didn't have to do anything within the Spring application.
And we can see that the application hasn't restarted.
Yeah.
But there is one thing that we can improve in our application. It's missing a web track. It's probably a good idea to have one. And in the case of this simple app, the tracks are being backed by this enum. So I'm going to change some code, and I'm going to say, let's add a web track.
So behind the scenes, the IDE is recompiling the application. DevTools is picking that up, restarting the Spring context, and then sending a signal to the browser, and you can see the change live in your browser while doing it.
So this is something that's really super productive for your app. You basically change code, and you can see along the way those change, how they work in your application without having to do anything. Okay, so let's fix this application because right now, let me show you that now because I haven't had the time to do so. There is this application secret property where we've hard-coded a user. We probably don't want to do that. We probably want one that any speaker or anyone willing to submit a paper to this conference can log in in an easy way.
Yeah.
Without having to register and create a profile and whatnot. And two, we would like to reuse that infrastructure to determine who's able to access the admin.
So if we wanted to do that, we need to write a lot of code, take care of resetting passwords, take care of many things. And for that, we could use an external mean of authentication for our application. And there are many.
There are many, but since it's a developer conference, maybe GitHub is a good way to do it. We could have used the Google API as well, but maybe not everybody has a Google account still.
Don't know.
Anyway, any speaker probably has some kind of access to GitHub. So we are going to show you now how we can replace that security config we have with OAuth 2 and single sign-on.
Yeah, that's what we'll do.
So the first thing we need to do is to add the dependency. That one is easy.
So because we're adding a dependency, whenever you're adding a dependency, you're changing the libraries that your application is using. So at one point when you do that, you have to restart your application. That's the limit of that model, but it's a decent limitation.
So I need to tell them I want to use OAuth 2 single sign-on. And the next step is actually to configure the application to define the OAuth provider that we are going to use. And there are a few properties that you need to set. And if you look at the Spring Boot documentation, you actually see examples of those, and there is even a tutorial that shows you how you can connect to GitHub, Google, and Facebook. So these values don't change. Once you know them, you're basically good to go.
Yeah, so with those, you've got where the access token endpoint is, where you can get the user info. Whenever that user is logged in, you need to get the information about that user. So all those information, they're needed, and you can use those as properties.
So the OAuth 2 protocol has some kind of workflow. You need to be redirected to a page, accept the fact that, OK, I'm OK, this application use my credentials on my behalf. So there is some kind of interaction before you actually can log in the application itself. And these properties basically define what should happen, what URI the service should contact. Next step is to have actually an application. So we need to define that application in GitHub. So quickly showing you how you can do that.
So you can go to your organization or your GitHub account, go to settings, and there's a dedicated OAuth application section in there where you can register a new application. And,
you can see that there is only one. We are going to ignore that one for now because it's a demo that we have prepared for later. I'm going to register a new one just to show you the full workflow. So let's say I'm going to show you during this presentation actually something you're not supposed to see. So that's the client ID and the client secret that the application is going to use to authenticate that application. But that's fine because I'm going to redirect. I'm going to ask GitHub to redirect to localhost 8080. So you're going to see a client ID, a client secret, which only works on your machine. So that's probably fine.
But if you do that for your own website, you're not supposed to share those, obviously. And you'd better store them into something that's not committed on your repository, a dedicated property file. OK,
done. I have an app, and GitHub has assigned to me those information, the client ID and the client secret. So I'm going to actually ditch this and specify the client ID and the client secret with those values.
OK, let's try now to see how it works.
OK, before we do that, there is one thing we need to do still, is we want you to actually log in if you want to submit something. So we are going to remove that line, which means that if you try to access it, you'll have to be authenticated somehow. So let's see how that workflow works.
OK, so restarting the application.
We have to, unfortunately, this time. Let's go back to the home page.
Home page.
Just to show you that it's still there. So you can still access the home page. It works fine. And if I click to submit now,
which is now protected, we're redirected to the OAuth 2 authorization page from GitHub. And you can
that browser session is actually connected to GitHub, so I don't have anything to do. But let's show you quickly if I had this. Let's go to submit directly.
So if you're not logged in, you have to
sign into GitHub first. Yeah. OK, so let's see. I'm agreed to authorize this application, and I'm here, and this is my user.
And we're logged in as a GitHub user. Good.
So that part is still a bit messy because you shouldn't have to provide those. We will show you how we can improve that in the next step. But before we do that, there's a problem. The admin section is gone.
Yeah, and in our application right now, we can authenticate, but we don't have that admin feature that we had. We don't have the admin role as a user, so we need to bring that back to our application.
So there is something in the Spring Boot and the configuration of certain areas have the concept of customizer or some interface you can implement to actually tune the way the application will be configured. In the case of OAuth, there's a few, and there is one called Authorities Extractor.
So basically, when you're authenticated with the application, you need a way to specify for a given user to guess or extract the information and tell this user has that role and that role. So in our case, if you're Stéphane or me, because we want it that way, you have the admin role, and if not, then you're just a regular user. So that's how we want to do it. So for now, we can just have a static list with our GitHub IDs here. And with this authorities extractor, we're checking if this is Brian or Stéphane, then admin, otherwise user. And in our case, yeah, we're back to getting the admin access.
So if you look at the code is quite simple, just checking and assigning role accordingly. So I need the role admin, because this is what I said right here. Okay?
Okay, but in our case, getting that static list into our application is not super clean.
So we want to change that, and this is something that was also shown during the keynote, and we want to go deeper about it. We want to explain how it works. We want to move that static constant to something that you can configure, and something where you can have assistance in the IDE like any other key if you used to use Spring Boot. So to do that, I'm going to take this, because that's a good default value for the app for now. And oh wait, I need to do something first. Sorry. I want also to fix this. Right? So currently, I'm actually binding on that key with that case. So capital case with underscore. This is really what I'm expecting. I want something more flexible. So I have something prepared so that I don't code too much, which should be CFP property somewhere. There we go. So I'm creating the CFP properties from scratch. I'm going to add configuration properties. So what does that do?
So the configuration properties annotation, it's basically telling the namespace where you want that configuration to live. So all of the keys that you're defining here will start within the CFP namespace, and then there'll be CFP, GitHub, security, and by using inner static classes, you can go on with that namespacing and define the custom properties you want. So
this file actually exposes two properties, cfp.github.token and cfp.security.admins. And one thing which is nice about that is that you're actually structuring the namespace of the configuration of your application in the code itself. So if you have areas for security, for whatever thing you want to configure for your app, you can have dedicated object for that too. So you can structure your configuration in code.
But like many features in Boot, we're not only providing features for you to use, but also the infrastructure for you to build on it. So in that case, we even had a red banner saying that something was missing. Because if you want to fully reuse the infrastructure, you not only need your application to, you not only need your application to know about that class, that it's existing and that it should consider it as properties, but you can also generate metadata, because those metadata, they're reused by your IDE, for example, and that's how we'll see what kind of feature that will bring you to the developing experience.
So we've been redirected to some documentation that states how it works. So you can read that at home to better understand low-level details. But I'm just basically taking the thing that the documentation says I should add, which is this. And this is going to add an annotation processor. So an annotation processor, for those who don't know what it is a standard compiler hook point where the compiler actually calls you with the model of the source code, and you have a chance to act on it, like generating a different class, inspecting the model and generating a resource file. You can do whatever you want. And this annotation processor basically scans the object that have configuration properties on it and deduce the keys based on the structure of the file, like we've just shown.
And while using that information, it's generating metadata, and that metadata can be read by any tool aware of that. So in our case, tools like IDEs, IntelliJ, NetBeans, and Eclipse STS, they all know about that format, and they can reuse that into their own features for autocomplete or for validation, etc.
So I just updated the code to use the CFP property thing. I can see that IntelliJ complains that it doesn't know about it. Indeed, if you look at this file, it's not meta-annotated with anything. So if I wanted to turn to a Spring Bean, I can just add component on it, and that will do the trick. There is a different way, if you want this to be more declarative, is to use the enable configuration properties annotation and add the class. And that's going to create a Spring Bean. And now I can see in my security config that IntelliJ doesn't complain anymore.
Yeah, so there are really three things to do to really enjoy this. It's creating a class and adding a namespace to it, making your application aware of those classes, and then for tooling, generating the metadata for those classes. And once you have all those three items, you're good to go, and you have the full Spring Boot configuration experience for your own configuration classes.
The other thing that's remaining is fixing this. And as you've seen, the case is different here. It's uppercase underscore. So let's just inject the properties like I did and replace this by properties.github.token. And it will still work. Yep. And it will still work because we managed to intercept properties coming from different environments. So when you specify an OS environment variable, usually you name it uppercase with underscore because that's how those variables are defined. And we detect that, and we will translate that case automatically to the target object. So it will still work.
Yeah, and if you check the boot reference documentation, you'll see the official order of how we are considering things. From some of those are more, they come into place before the others. So environment, properties files, etc.
So if I do that, I get the auto-completion, I get the same description. So I can basically do anything now, and I can add admins to the app. So let's see. Let's go back to my app. Should work, right?
Yeah. So by default, it's still you and me.
OK, so let's see. Let's say that only you can access now.
Great.
Yeah, you like that, right? So if I do that, OK, I have access denied, which means that the property has been changed. And we're back on the ugly error label page.
Yeah, but we only have a 404.html page. So you'd have to copy and paste it to have a 403.
Let's do that?
Yeah. Or...
Nah, let's not do that. OK. One more thing that we did for error page is this. So,
which makes sense.
Which makes sense, and now I have the error page. So the way it works is it's using a fixed pattern. So if you want a default page for client-side error, you just name a file called 4xx.html. We're going to use that. If you want a specific page for 4.4, though, just create a 4.4 like you used to, and it will use that. And the 4xx will be used as a fallback.
But in our case, it's still saying page not found, where obviously it's a 403.
That's not good there. So let's fix that. So remember, it's a template, and because it's a template, you can do whatever you want with it. So why is it uppercase now?
So in our case, we have access to the actual error happening, and so you can use that object to customize your template and do something about it.
I think I made a mistake. What
In
now?
Those are the quotes. There's an extra quote, single quote after error.
Yeah. That's bad. Okay.
Good.
So, oops, forbidden. And if I go there, oops, not found. You can also get the path. You can also get the timestamp at which the error has been generated. You can get, basically there's a class called error attributes. You can actually create your own. And everything that's in the model for that particular error is being injected when the template is processed.
Yeah. You might want to re-add yourselves to the admin list.
Do I? OK. So there's an easier way to just do this.
Okay.
And probably go back to admin just to prove that it works. Yes.
OK. So right now, we have an application powered by OAuth 2 for authentication. But there's one thing that's still missing, because we still have that email and name information in our form where we clearly don't need that anymore, because we know who you are. So in that case, we'd need to somehow plug into the authentication mechanism and get our own user concept and have that into our own database tables, et cetera, et cetera. That's a lot of work. Fortunately, you had it ready.
Yeah, I mean, look me typing while you're explaining. It was fast, right? OK, we're not going to live code that because it's quite a lot of work, but I think it's important that we show you what we've done. So one thing we've done is creating a user dedicated object in the database, and just instead of having the email and the name in the submission, having a link to the user. So that's easy. So it's a way for you to know which submissions a particular speaker has created. Then we need to
do something about the security configuration. Like I said, you need somehow to plug into the authentication mechanism to do something about your user. So by default, it's you get the OAuth information coming with the user endpoint, OAuth user endpoint. And here, in our case, we're using the principal extractor, which is a way to hook into the authentication mechanism and extract all the information we need and turn that into our own user object. And that user object will be available within the whole application for you to use, to inject in your controllers, etc.
So the funny story about it is, if you go on news, there's actually a commit for that, like 2 days ago. Previously the demo was not that nice, because we had to play with events and catching stuff and creating the user in a place where we didn't want to. And we didn't say anything to Phil, nothing. And one morning I wake up and he did that. So we took the time to reuse what he has done. So typically what that means is, whenever you go to this app, it's going to create a user entry automatically. So let me show you that quickly. So this is also a feature of DevTools. If you have H2 on the class path, we will automatically expose the H2 console, so you can see the content of your database. So I can see that my user has been created just by the fact of logging in. And because the principal extractor now associates the user as the authenticated object, we can actually use that information and inject that into controllers to link the submission with the user. So this is what we do in the controller.
Yeah, so that part is regular Spring Security feature. You can use the authentication principal annotation, which is an argument resolver. It's trying to get the principal and resolving it and typing and casting that to the right class that you're expecting, and injecting that user information into your controller. So that way, we know who's calling that controller handler, and we can do things about it.
So let me create maybe something, right? OK.
Yeah.
Thanks. And if I do that, and I go back to the H2 console, I can see that Bing's I can see I have my submission with the speaker ID reference. So that was quite easy, actually. Getting an auth to give us a callback, creating the user on the fly, associate that as the authenticated principal. We can inject that easily in the controller and make the link between the two.
And remember, when you check the actual code repository we'll put online, you will see every step. We've separated each step as a separated commit with the message and everything we've done. So that step you'll be able to see what we've done, including in the templates, because we didn't have time to really show that.
Yeah. So one thing which is still a bit worrying about this app is the GitHub integration is not cached at all. It's pretty much the same thing as what we saw during the keynote, but again, we want to go further than the time we had for the keynote. So if I check the rate limit, I'm in like
we're down to
4968.
So a few calls, right?
Yeah. And I can see that it's decreasing.
10 more. Okay.
Okay. So let's change that. So again, what you need to change that, it's quite easy. One is you basically add the starter for it. And you enable the caching mechanism. Easy. And once you've done that, you can go on any service or any Spring Bean, and
in our case, the GitHub client calling the GitHub API.
Right.
And on those specific methods we want to cache, we're just adding the cacheable annotation with the cache name we want to have for each. So we have one method getting the most recent commits for a specific project. And on another case, we're browsing the list of all commits until we find the first commit saying publish into the commit message. And of course, we've got the user endpoint, because every time someone is logging in, we're fetching the user information.
Mm-hmm. So if we restart the app now, what's going to happen is you'll get a basic implementation, because we don't make any assumption of the kind of caching library you should use. There's plenty out there, open source and free, but we don't have an opinion about it. So we don't want you to force to have a caching library by default if you use the cache starter. So what you'll get instead is simply in-memory caching using concurrent hash maps. Mm-hmm. Very basic. So maybe what we could do is use JCache instead, so the GSR 107 specification. So for that, I need to do two things. I need to add the cache API, and I need to add a cache provider, which is GSR 107 compliant. Again, plenty of options. So cache API, and let's go with EHCache. OK, so I need to restart because I changed the class path again.
And because now we have a cache implementation, we can do more things about it. We can customize what's going on, how our cache is reacting to values being stored in it. Actually,
that might break, yes. So it will break. Why? Because JCache has no concept of creating a cache on the fly. So I've defined 3 caches, and I'm asking basically Spring Boot, Spring Framework, to intercept those method calls and interact with the cache for me. But when I ask the GSR 107 provider, please give me the cache name github.commits, there's none. And that's why you get this exception. So let's create the configuration for those cache. Again, it's something that you'll see in many places in Spring Boot. There is a customizer that you can implement, and we will call you with the service, with the cache manager in this case, and you'll get a chance to do whatever you want. So it is named JCache Manager Customizer. And if I do that, I basically get the cache manager.
Yeah. And in there, we can hopefully define the caches we want to have.
I can do that. I can create a cache. So I'm going to have this config, this method, which initializes the config for me. Statistics enabled, very important if you want to see the hit-miss ratio in the metrics. Store by value, that one is a tricky one. So when you use DevTools and you store a serialization version of the object, when you deserialize it, it may not be on the same class loader. So let me explain that. You cache something, you serialize it. You serialize it with the class loader of the library, not the one of the application. When you restart the application, the class loader change. The class loader of the application change, but not the one of the library. And when you try to deserialize the object to have a class, the class has changed. The class reference has changed, so you get an exception. So there's two ways you can work around that. Store by value, which is what we're using now, and there is an option, there is some configuration in DevTools to bring certain libraries to the application class loader, so that if the application restarts, you'll get the new class loader with it. Okay, so let's say GitHub's commit. I'm going to say 10 minutes.
10 minutes, fine. I mean, we're not doing a lot of work right now, right?
No, especially now. Polish commit. And for that, I'll say 10 minutes.
Okay. And user?
And user, GitHub user, I'm going to say 1 hour.
Yeah. Good. So now we have our 3 caches and a specific duration for each. And restarting the application should work now.
Hopefully, if I didn't make any typo.
Good.
Which I usually do. Okay. So now it's being cached. So the first user that requests this home page, the next one will get a cache version of the GitHub data for 10 minutes. And if you log in, and if you for some reason we remove the user from the database, which shouldn't happen anyway, you'll get a cache version during an hour.
Okay.
Okay. That's all nice and clean, but so far we don't have any database schema management at all. So every time the application is starting, we let Hibernate create the schema for us. And every time we do a change, the in-memory database is reclaimed and you get a new one. So basically, if you put some submissions to test some stuff and you restart, well, they're gone.
Okay, so let's pretend now we want to move to a SQL database, a real database to persist at least our data. We could use any other database for that matter.
Yeah.
And now we can choose that, and there's also we definitely want to show you a couple of things with Flyway as well.
Okay, so let's start with Flyway.
So in case you don't know Flyway, it's a great tool for managing your database schema and migrations during your application lifecycle. So you'll see how it works actually.
Yeah. So let's see with an example. That will probably be easier.
Yeah.
So let me create a file. I think something
so with
like
that tool, there are conventions with Flyway on how to name your SQL files, and those SQL files are executed when your application starts, and Flyway is checking if your database is already up to date or not. So here we are, for the first version, we are describing the actual schema we want to have in our database.
So we can try that actually. Let's try that on H2 for now. So what's going to happen, the database is empty. There is no Flyway metadata in that database. So it's going to create a table to record the diff that were applied on that schema. And if there is, obviously, since it's a new database, it will basically run all the scripts. There is only one for now. So if I go back, hopefully it still works. Yep. And I can go to the Flyway endpoint, and I can get the information about the state of my schema. So my schema is at state v1, version 1, right here. It's a success, and you get some metadata about it. But that's not very, very interesting. Maybe we should switch to, I don't know, MySQL, for instance, let's say.
So for this, we need the actual SQL driver and a database that runs here locally on our laptop.
That's my laptop, you know, not yours.
So you do have a database running, right?
Yes, hopefully. Okay, so let's see that. Let's connect to the local database. I've created a CFP one, which is empty for now.
Okay.
One thing we want to show you is how you can switch from one environment to the other very easily, including using your ID to assist you. And the easiest way to do that is to use profiles. So I'm going to create a local profile. So the convention is application dash the name of the profile. So application dash local.properties. And I have some config here.
So here we're describing the data source that we will use for local deployments. So here the database is on localhost, it's MySQL, and we've got the username and password.
And you can hack my CFP database all the way you want if you know my IP, right? And it probably doesn't listen remotely anyway.
So if you want to
Right.
use that, you need your application to be aware of that profile. You need to activate that profile when running your application.
So one thing which is nice, be it in IntelliJ or STS or NetBeans, is that you have those run configuration, you can do something about it. In IntelliJ IDE, it's quite nice. You can clone it, give it a different name, and there is a shortcut here to enable the profile. So you can do this. And if I start this app now, it's not going to use H2 anymore. It's going to use MySQL instead. I can see that the profile has been enabled because Spring Boot tell me so.
Yeah.
And if I go up here, probably need to refresh something. I have my schema, and I can start working. I can start inserting data in it, and basically get that experience. If I want to go back for performance reason, whatever the reason, to H2 in memory, well, you just use the other run configuration without the profile, and you're good to go. Yeah. Application-local and application-secret, by the way, are not supposed to be committed to your Git repository. The secrets, it is for the sake of the demo, because otherwise it wouldn't work. But usually what you would do is add that to your Git ignore and just have those locally with your own settings for your own DB, for instance.
So what happened during startup of our application? Flyway checked the database. Flyway saw that there wasn't any schema, so it rolled in the first SQL script we had to create the actual schema, etc. Now our database is in version 1, and we can add whatever data we want and do whatever we want with our database and continue developing our application. But the whole point of this you want to add something first?
No,
yeah,
go ahead.
Go ahead. The whole point of this is that you can keep working locally on your application, but also in production. And at some point, if you want to change the schema, you can do it.
So at some point, we figure out that maybe it would be nice if the speaker could add some notes for the committee, which is a simple additional column, and we would like this to be completely transparent. And that's where tools like Flyway really shine, because what I have to do is only do this, basically. If you don't look at the rest, because that's basically adding the field to the system. So just creating a script with a given version. In this case, we want to switch to version 1.1, which also involves that you have some kind of versioning, depending on the application. And I'm just going to add a field to my submission table, and these changes are basically about changing the schema, so it's the structure.
Adding everything in the form, etc.
So it's not very, very useful. So let me check out that. And if I restart, well, I don't have to restart, actually, if I just refresh with DevTools.
So now in our form, we've got the new notes field. And if we check the actual status of our database, we can see that we are now in version 1.1, excuse me, and that our second script has been applied to our database.
So how does it work if you have a production system? So cfp.cfapps.io is the previous version of our app, which is running on Cloud Foundry. So if I go here, I will basically get the old version. And I'm an admin, so I can actually show you the Flyway endpoint. So,
and I think we've created a few entries.
Oh yeah, we did.
So yeah, just
to prove that it actually has some data in it. Okay. So what does it take once you have a system in production to upgrade your schema? Well, just push a new version of your app, and everything will happen for you. So we want to quickly show you this. So I'm probably going to take master, package the application. And if you want to update an app, if you want to update a Spring Boot app on Cloud Foundry, if you've never done that before, you see it's quite easy. So cf push, cfp, that's the name of my app, and the reference to the application, and that's it. And that's going to update my app for, in the cloud environment.
Okay, so we are uploading the jar. Obviously not everything. It's detecting what changed, so we're not re-uploading all the dependencies in the jars. And once it's done, it's restarting all of our instances for our application. In our case, we only got one instance. And it's running the build pack to guess if it's a Java application or a Node.js application or whatever. And it's bringing the application online.
In like 1 minute or so.
Yeah.
So while this is doing, we thank you for your attention. And if you have any questions, we have 2 minutes left. Thank you. Any question? No question.
We'll take embarrassing ones.
Okay.
No?
If you're shy, you can come to us after the talk.
And remember, the whole repository and all the code and everything is really explained in all the commits, so you can take a look at it. Okay.
Done.